Hello, my name is Mina. It's a pleasure to be presenting in ASCAAD conference. My name is Parametric Simulation and Sensitivity of Light Shelf on Daylighting and Shading Light Shelf Performance Map. So in the beginning, we know that daylighting has many benefits to the human eye and also can improve the performance of students. Besides, it has dynamic characteristics that change over time and latitude. However, it also has to be controlled from direct sunlight and the glare. So one of the daylighting and shading devices that is commonly used in schools and well known for regulating daylighting is the light shelf. So the challenge here is to how to reach the optimal dimensions of the light shelf given the dynamic characteristics of the daylighting. The contribution of this work is to devise a performance map based on two pillars: the real climatic conditions and the dynamic calculation of daylighting. So the paper uses a parametric approach to simulate daylighting using radians, in which 11 light shelf models are modeled in a typical classroom with a changing size of the south window. And it develops this map based on 3 locations, which are Stockholm, Cairo, and Nairobi. So the first findings of the research is that large windows do not necessarily increase daylighting illuminance at the back of the room, but only across the width of the room. The second findings regarding the seasonal daylighting are best fit lines. We can see that in Nairobi, extreme daylighting enters and falls very sharply as the sun has the highest elevation angle in the sky, while in Cairo, daylighting decreases gradually. And in winter in Stockholm, direct sunlight enters across the whole room for most of the time, which is hardly to be blocked by a horizontal device. Regarding the annual daylighting, light shelf 80 times 120 had the strongest impact on improving daylighting in Cairo than Stockholm, while in Nairobi, daylighting was improved slightly by internal shelf more than by the external shelf. For the light shelf sensitivities, radar charts or diagrams can provide more insights into the strength and weakness of each light shelf with regarding to the daylighting objectives. So we can see that with regards to the shading performance, light shelf 80 times 120 outperforms all the other shelves in the shading with relative reductions from one city to another. And with regards to the daylighting in the middle of the room, we can see that the internal light shelf can increase a little bit or slightly. Almost all shelves in Cairo like offset the direct sunlight and reduce the useful daylight. With regards to the daylighting improvement at the back of the room, most of the shelves improved daylighting very slightly, like the light shelf 80 times 80 or 60 times 120. With regards to the average uniformity, we can see that the longest light shelf improved the average annual uniformity in almost all latitudes and significantly in the equator. So the performance map developed in this work used the best fit quadratic regression method. We can see that the range of shading effectivity of the all shelves is smaller as we go from the equator to the north, while the internal shelf could improve daylighting very slightly and they do not play a role in the shading. So for example, here we have a Munich with latitude 48 north, and we can reach an estimated value for the annual daylighting using this map, and moreover predict the effective light shelf or the most shading device used in this latitude. So the most effective light shelf reduced the direct sunlight with about 20% of the year. And the same goes with the useful daylight in the middle of the room. We can interpolate Munich and get the useful daylighting in the middle of the room. So in the end, it is important to know that these are preliminary design curves which need to be validated in future studies, and other factors also should be included, like sky cloudiness. Thank you very much for your listening, and I'm looking forward for your questions and comments and feedback. Thank you very much.